Welcome. This is Ronald Van Oostveen for East Marsh Acres, and what I'm going to do today is tell you a little bit about the task that I have at hand, so the job, project, whatever you want to call it, that'll make the house a little bit better than what it is right now. So as you are aware, if you've watched any of the videos on the channel, the house is ICF construction. Basically, that means that it was built with insulated concrete forms, which means that there's 2.5 inches of styrofoam on either side of a 6 or 8 inch. In our particular instance, it's an 8-inch center of concrete that has rebar in it, so it's reinforced, etc. And the walls then are enveloped in, again, another 8-inch layer of styrofoam outside of that goes around the entire house. So you end up with these very thick walls. So you can see that the wall here, including the door, is approximately 22 inches wide, something along those lines. We've got an insulated door. The windows are the same once the amount of brightness settles down on the iris in the camera. The floor is the other piece that is part of the Passive House standards. So this floor is slab on grade, so it's a piece of concrete that was poured over the surface of the land. But before that, we had another 9 layers of concrete, or sorry, of styrofoam below that. And then, of course, there was a layer of material that doesn't allow moisture to seep up, etc. So this is an insulated floor of concrete, but the concrete also has a series of pipes, and you can go back to an earlier video where I show you all of the pipes that were laid before the concrete was actually poured. Those pipes are going throughout the entire floor of the house itself, and they're all connected to this box that is embedded in the floor itself. Inside the box, there is a series of heater coils, so 3 coils that get hot, and there's a couple of fans that will move air through the pipes throughout the entire concrete pad. So we have passive radiant heat that is coming through the floor, and this is all regulated by a thermostat that we have on the wall here. And we set the thermostat at 20 degrees, which means that the floor is about 20 degrees all the time. And that goes throughout my office, Trisha's studio, and the storage room that's behind it, the opening to the front door that you see there. Going back down the hall, it's also under the staircase and into the storage space here under the stair, and it's also in the laundry room. So what we're trying to do is provide a constant source of heat, radiant heat coming from the floor itself, that will end up heating the room above it, so the room that you're seeing here, the laundry room, and the rooms above it, because heat rises. It moves from the floor and up through the actual rest of the building itself. Except that we have a dryer here. It's a regular dryer, energy saver and all those kinds of things, but it's connected to a hole in the wall, a 4-inch hole in the wall that leads directly to the outside. While there's insulation around the pipe and the hole in the wall, that pipe itself leads to the inside of the dryer, and the inside of the dryer is almost the same temperature as the world outside. So when there's no heat in the dryer, we are losing heat through the dryer to the outside world through that uninsulated pipe. So what I'm going to do today is build a plug out of styrofoam. So I've drawn one out already, and I'm going to shape a couple of layers. So I'm going to put 2 layers of this foam together. I'm going to glue them together. I haven't figured out if I'm going to actually do more than just gluing. We'll have to see how well they stand up as we're putting it together. And then I'll put a top plate of wood on the outside so that we can, and that wood will have a handle on it of some kind or other, so that we can pull the plug out when we need to use the dryer, and you push the plug back in when you don't need the dryer. This is an issue that you have with all things that are actually poking through the wall itself in a passive house. So there's been a lot of talk, and I've done a fair amount of investigation on the internet as to how to best insulate this hole so that we don't lose a lot of heat through it. But it also happens where we've got things going through the wall, so that in behind the laundry sink here, there's also another external tap that leads to the outside, right through the wall itself. We also have, back into the mechanical room, spaces where all of these cables that are needed for the electrical system and for our solar power, and I'll do another video on our solar connection, which we just got running 2 weeks ago. It's been running for 10 days or so. Anyways, all of these poke through the wall in some place. Here's an exception. So here we have a power cord coming through, but it actually comes up through the bottom of the house, because we had the conduit that you can see there already in place when we poured the floor. The other exception is where the water comes through. So this is the water that is coming up from the well, which is in behind this wall. It's in behind the wall, back in the about probably 4 or 5 meters away from the house itself, and the hose from the well is buried underneath the soil, and then it comes up through the pad, the heated pad, into the house, so it's not going to freeze. Again, there's an external tap that we have to ensure is well insulated. So there's foam around all of these pieces, but an open vent, like from the dryer or from above the stove, are not insulated, and as a consequence, we're going to be losing heat from those particular sources. These are not the only places that we're losing heat at this time. This is a new house, and we need to do a pressure test at some point in time to figure out how weather tight we are. And I know that there are several places that will need to have additional insulation in the form of spray foam applied, and some places around some of the windows, etc., they need to have the trim taken off and then spray foam placed on the inside to cut off some of the draft that we're actually following or finding that's actually occurring. So we're losing heat in a number of places, and until we actually solve those issues, we are going to be paying more for our energy than we probably should in a house that is close to passive standard. But in the meantime, we have no additional furnace. We have no additional heat sources other than the floor We have some spot heat sources that we can turn on in the form of a couple of mini splits or 3 mini splits upstairs, and some baseboards that we were required because of building standards to actually incorporate into the building of the house as well. Anyways, I'm going to go back to work in the garage and see if I can build that plug that I was talking about, and then we'll see what it looks like when we put it in place. All right, so it's the next afternoon. I didn't get the project finished, but I'll show you what I do have, and then we'll get to trying to finish it. So anyways, I had to shape 2 plugs that fit into the size of pipe that we have, and this is a 4-inch pipe for venting a dryer. So that's what I'm doing here, and then I'll have 2 of these pieces so they'll fit as snugly as I can possibly get them into the space. So 2 of these on top of each other. I'm going to slide the bolt through it, and then on the front side, so we have a plate that's not going to slide into the pipe itself, I'm going to add this piece of wood, and I'm going to put a handle across it. So I didn't need to build 2 holes into it so that I can put the handle into it so we can pull the handle directly out. And then I need to put a hole for the actual bolt itself that's going to go down through the center. So I've got all the pieces now, and all I need to do is actually put them together. So I'll take you along on the rest of that journey. Okay, first things first, I need to find a drill bit that will match the size of this carriage bolt. And I've got a selection here. So let's see what this is. It's 5/8. I think this is going to be bigger, smaller than 5/8. Yeah, for sure. So let's go with 1/2 inch. That's 5/8 as well. I've got duplicates of a fair number of these. So this is 3/8, and I think that would fit it. So I think this is a 3/8 bolt, but I'd like to have it a little bit larger, so I'll look for a 1/2 inch. There's a 1/2 inch drill bit. Plug that in. Let's see how I'm going to do this. Okay, doesn't really have to be exact. Just going to okay, got my hole. And then the question is, what kind of hole do I need for the rope? And again, I think the rope is going to do fine with the 3/8 bit. So I think the 1/2 inch is actually fairly large for this rope that I've got. Yeah, it is. So I'm going to, this is going to go. Let me show you what I'm doing. I think that'll do. Much. Much sharper bit than the last one. So now let me put same hole on the other side so I can tie the piece of rope in on both sides. Clamp it in. Seems like a bit of a waste to clamp it all the way down, but and again. Okay, and there we go. Little bolt. Oh, it's a 1/2 inch bolt. Look at that. A little bit of persuasion, never hurt. And we put the piece of styrofoam in the second piece. So they're more or less in line with each other. And then I've got just a little plate to go on the end inside, and a nut to go on the end of the bolt. What I really should do is put a second bolt on here. So the entire thing can't come loose at some point. Don't think it will, but okay, then I take the pair of pliers. Okay, I think I've got it. So that should fit quite nicely. Let's see what we can do. I'm going to clean up in here and then I'll bring it over. Okay, I'm pulling out the space, the dryer. You will note that I already have a docking system here that is meant to make it easier to detach the dryer from the vent. It's got magnets built into it so that it actually just attracts on both sides. I don't have foam filled through the entire thing. That's what that other piece of pipe is actually intended to be, but you can see that there's a 4-inch hole basically that goes all the way through the outside wall, which is 22 inches thick, and it's got a 4-inch hole that's allowing air to escape into it. We'll just plug it. The intent was so it looks like this hole is a little bit smaller than the other one, so it's not fitting. So I'm going to have to do some more adjustments. And I need to actually do a little bit more in terms of actually fitting this particular piece on. This is just temporary because it's not long enough to actually go through the entire wall. But it's a first approximation. So I'll be back. Okay, I did a little bit of trimming along the edges, and so now the plug fits snugly into the actual tube itself. And now I'll just place the tube back into the hole. Okay, it's very, very rough and needs to be fixed because now we have an even larger hole that's coming through the wall. But I will figure out how to fix that at some point. I don't know exactly how, but we'll get there. Anyways, I'll post this as soon as possible, and we'll talk to you soon. Bye.